want to talk about these right here. That's not big enough. Those right there. When you see those triangles going in the same direction on two lines, that's an indicator of parallel. So those two arrows tell me that these two lines are for sure parallel. And I need to know that to be able to use this nice postulate. So we have two parallel lines that are cut by a transversal. Then you have each pair of corresponding angles. Okay, so the corresponding angles are going to be congruent. Now, we had these arrows that indicate the parallel, but I want to go ahead and label our angles. So remember, 1 and 5 are corresponding, they're in the same position. 2 and 6, 3 and 7, and 4 and 8. So angle 1 is going to be congruent to angle 5. Angle 2 is going to be congruent to angle 6. Angle 3 is congruent to angle 7. And finally, angle 4 will be congruent to angle 8. The reason this is a postulate and not a theorem is because the parallel lines tell us that these lines are in the same slope, and if they're in the same slope, then the same amount of distance will pass between the transversal and that line. And if the same amount of space passed, then they have the same angle measured. So does that make sense? And so what I usually do is I go ahead and I label the ones that I know correspond. Yellow short. Yeah, it's just enough. Okay. So I know 1 and 8 are the same, and 2 and 7, and 3 and 5, and 1 and 6. And I can use this information to find missing angles. So they're telling me angle 5 is 72. So that's this blue one here. And I want to find angle 4, which is this yellow one here. Well, 4 is the same as 6. Can I find 6 if I know 5? Yeah, because it makes a straight line, right? Mm-hmm. So if angle 5 is 72, angle 6 is 180 minus 72, which makes it 108. And if angle 6 is 108, angle 4 will also be 108 because they correspond. So 108. Well, angle 5 is still 72, and I want to find out angle 2. Angle 2 and angle 7 are the same. Do I know anything about the relationship between 5 and 7? They're vertical angles, right? we have a cross. So they're the same. So 5 is the same as 7, and 7 is the same as 2. Okay, and then we were supposed to tell what postulate or theorem we used. So in order to find angle 4, I first used the linear pair, the fact that 5 and 6 were linear pair. And then I used the corresponding angles postulate, which is the one that tells me that those corresponding angles are the same. For number 2, I first used vertical angles. That was 5 and 7, and then the corresponding. Questions on that at all? Same setup, but we're going to say that 8 is 105. Okay, so 8 is 105. If we know what 8 is, we know what 1 is, because they're corresponding. If we know 1 is 105, I can find 2 by subtracting from 180, so it's 180 minus 105, so 75 degrees. And that's a linear pair issue. I guess it's not an issue, that's how we find it, it's linear pair. And if I know 2, I know 3 because they're vertical. So our path here, we were given 8, which was the same as 1. We used 1 to find 2 by subtracting from 180, and then 2 and 3 were the same. So I went straight from 2 to 3 because they're vertical. So that was our path we could take. We have 3 new theorems. These theorems can be derived from what we were just doing on that last example. If you have 2 parallel lines and they're cut by a transversal, so again, these arrows indicate the parallel, and we have our transversal, then alternate interior angles are congruent. And if you remember, our alternate interior are 3 and 6, and 4 and 5. They're on opposite sides of the transversal, but in between the parallel lines interior. So angle 3 will be congruent to angle 6, and angle 4 will be congruent to angle 5. Okay. Then we have interior, doesn't have another N in it. Okay, so interior angles theorem tells me if 2 parallel lines are cut by a transversal, then consecutive interior angles, that's the same side, are supplementary. So 3 and 5 are consecutive interior, 4 and 6 are consecutive, so I get angle 3 and angle 5 will add up to 180, and then angle 4 and angle 6 will add up to 180. Okay? And then you get the alternate exterior angles, which tell me that the alternate exterior angles are congruent. So 2 and 7 and 1 and 8. So we had that alternate interior angles are congruent. So this angle is the same as this angle, and this angle is the same as that angle. While vertical angles tell me that this angle is the same as this angle, and this angle is the same as this angle. Those are my alternate exterior on one side, and then this angle is the same as that angle, and this angle is the same as that angle, and these are my alternate exterior on the other side. So I end up with, out of 8 angles, only 2 angle measures. And it makes like a checkerboard pattern, so I have red, blue, or blue, red, blue, blue, red. So if you make this pattern every time, and you don't have to use color, you could use like, star and square or circle and square or something, but if you make that pattern, you know that all the ones that match will be the same. So all of these red ones are going to have the same, all the blue will have the same. And then I have my consecutive interior angles theorem, which tells me that these two add up to 180. So any of the red ones and any of the blue ones. So I could pick, this red here and this blue up here, and they'll still add up to 180. So any red plus any blue will add up to 180. So you only have 2 scenarios. Either the angles are going to be equal, or they're going to add up to 180. So there's only 2 things to think of. Can't read that very well, but this was Creek Road, and that's Reading Lane surrounding Wendell Park. And Park Road is their transversal. If angle 1 is 118, we want to find angle 2. So what I always do is I go through and I kind of mark my checkerboard. So all of those are going to be the same, and all of these are going to be the same. Well, I can see that 1 and 2 are the same color. So if angle 1 is 118, so is angle 2. And then if I were asked, well, what's angle 3? Well, one's red, one's blue, so I would do 180 minus 118, which would be 107 minus 8, so 62 degrees. So then I would have 3 and 4 are both 62, because they're the same color. Using the same diagram, if I know angle 1 is 100, angle 4 is red, angle 1 is blue, so they're going to have to add up to 180. So I do 180 minus 100, so 80. And if angle 3 would happen to be 70, well, 3 and 4 are the same color, so they're the same measure, so they're both 70. Different variables. Those are the same. Those are the same. Checkerboard. So angle 4 and angle 1 are 2 different colors, so I don't know if you can see those still. So 1 and 4 are 2 different colors, so they're going to add up to 180. So angle 1 is 85 degrees. Angle 4 is 2x minus 17, that equals 180. 85 minus 17 is 68. Subtract 68 from both sides. Divide both sides by 2. that's one scenario where you'll have two things that add up to 180. And the other scenario is you look at 3 and 7, they're the same color, so they're equal. So angle 3 equals angle 7. They are alternate interior angles. So 4y plus 30 is equal to 7y plus 6. So I'm going to subtract 4y from both sides. And I get 30 is equal to 3y plus 6. And if I subtract 6 from both sides, I get 24 is equal to 3y. Divided by 3, y is equal to 8. The perpendicular transversal theorem tells me that if I have two lines and they're parallel, so sorry, I should have had the indicators. So these are parallel. And if a line is perpendicular to one of the parallel lines, then that makes it perpendicular to the other. Which makes sense, right? Because we know that if this is 90, this is 90, this is 90, and this is 90. And since these are all, you know, congruent to these, and if these are all 90, that means that these are all 90, so it would both be perpendicular. Just kind of makes sense. I hope.